For
For
different
example,
SVI, different subnets.
different subnets.
Yes.
For example, VLAN 10 we are using 10.1.1.0/24. So we have to use this SVI interface same subnet or different.
For SVI for VLAN 10 will have this subnet. For SVI for VLAN 20 will have different subnet.
Yeah, different. But I am asking you, sir, when we you're using to assign IP for the PC, that way you're using
Yeah,
10.1.10
same
for the
brother,
subnet
same.
for
Your
PC.
SVI is a part of
Same.
that VLAN only, right? The PC,
Okay,
SVI
okay.
interface, all will have IP from the same subnet only.
Okay, sir. Okay,
So
okay.
just configure the last IP address from the from the subnet
Yes,
on the SVI interface. Rest
yes.
all
I
the
try
IP.
with the switch. Yeah, switch and router. It's working. Yeah, yeah. Okay. Thank you, sir.
Yeah, yeah. Anything else?
सर
Mm-hmm.
सर मैं जब यूएनजी इंस्टॉल कर रहा हूँ ना सर, मेरे को उधर एरर दिखा रहा है।
क्या एरर सर?
मैं इतना नोट नहीं किया। जब हम यूएनजी जो ईएमएल में वो फाइल ये करते हैं ना, आईएसओ फाइल जब ओपन करके उसमें डालते हैं ना सर, तभी वो मेरे को एरर दिखा रहा है।
जब
स्टक
भी
हो रहा है
कुछ
उधर ही वो।
एरर आता है उसका एक स्क्रीनशॉट तो लीजिए कम से कम, तभी तो कुछ समझ में आएगा कहाँ पे क्या एरर।
हाँ ठीक है
ईवीएनजी
सर,
आपने
अगली बार मैं।
इंपोर्ट किया था मेरे वीडियो से।
हाँ सर, वही किया था मैं।
एक बार उसका
अभी
लीजिएगा स्क्रीनशॉट, अभी जब भी एरर आता है ना नेक्स्ट टाइम।
हाँ, अरे बस सर, जब यूएनजी इंस्टॉल करते हैं ना जो लैपटॉप में, तो उसमें रिक्वायर्ड क्या क्या रहता है? जो प्रोसेसर i5 होना चाहिए क्या? i3 में
सब
भी चल
सब
जाता है
में
सर?
चलता है, आई3 में भी चलता है।
ठीक है सर, ठीक है। नेक्स्ट टाइम मैं स्क्रीनशॉट भेज दूँगा।
या श्योर।
थैंक यू सर।
कोई लास्ट टॉपिक से क्वेश्चन नहीं पूछ रहे हैं?
Please, I also requested for something, but I think no one answered me. I requested for a TFTP server. I don't know if someone can help me with this file, but it seems like no one.
So if someone has the file, then only they can help you, no brother, for the
Yeah,
TFTP. It's simple, you can download it from the Google. Don't know
I,
why you are
I I
not.
tried to download, but it's asking me for business email, which I don't know.
Let me check if I have the TFTP. Wait a minute.
Okay.
Cisco software. Here it is. Okay, share your mail ID. Put your mail ID in the comment section. I will share. I have the TFTP.
Okay.
Put your mail ID here in the chat, and after the class I will share with you. Or you can just put your mail ID in the group only, WhatsApp group. In your WhatsApp group. Put it in WhatsApp group. I will share after the class.
Okay. Okay. All right.
Now let me ask you then some question from the previous topic. Guys, my SVI interface is down. What can be the reason? My SVI interface is down. Showing down. I have created the SVI. Ran no such command. Configure the IP. But SVI interface is.
Either the
There is
port
There is a point.
or
there is
they
What shut?
One by
What
one.
can be shut down?
Port can be. I told you no, that I have ran no such command.
There
No
is no
such.
switch port in VLAN. So we need to create a VLAN, L2 VLAN, and then there should be a switch port in that VLAN.
Okay, I have
interface
verified
is
that. I
defined.
have verified the
No,
VLAN database. And VLAN is there.
Interfaces is not defined.
no. With the SVI, I think we have to go inside,
Interface shut down.
not the sub interface. The interface itself to unshut it.
What I am saying,
Maybe administrative
I ran
shut
command.
down the
Sir, there will be not
You
ELAN
cannot see your screen. Can you
particular
share
port,
your
sir.
screen?
Port, okay.
Can you share the screen? We cannot see the screen.
No, I am not sharing that. Just I am asking you. that my
Okay.
SVI interface is down, and let me tell you what configuration I did on the switch. Access the switch, run command VLAN 10, it will create the VLAN 10. After that, run command interface VLAN 10, then no shutdown, and IP address 10.1.1.1, 255.255.255.0, exit, IP routing, and after that, when I check the interface, it's showing down. So what can be the reason?
Access port is not defined, and or the VLAN is not allowed in the trunk.
There is no any user in that VLAN on the switch, right? Let's say I have created the SVI on VLAN on switch number 1, and there is no any user in VLAN 10. There is no any
Can you
user.
draw it? Can you draw it here? It's confusing everything.
Yeah, there should be a user in that VLAN, and the switch port should be an access port.
Switch port should be access port.
The switch port should be a
No,
trunk port, not
it should be a
access.
trunk port. The switch side should be a trunk port.
Very
IB
good.
routing.
Very good. Maybe trunk link is not there on your switch. Now I am saying I have configured the link as trunk as well. This is my switch 1. Hope is screen is visible. Switch 2. And this link is trunk link.
Okay.
Trunk link. And here I have SVI for VLAN 10. Okay. No such command is already running. But SVI is down. There is no any user in VLAN 10 on switch number 1. What can be the reason? Link is trunk, VLAN 10 is available in the VLAN database, still SVI interface is down.
So if there is no user on switch,
Maybe sir, there will be protocol issue.
if you have allowed all the VLANs on the trunk, then no issue. If there is specific VLAN allowed, then you need to also allow the VLAN 10. And on switch 2 or switch 1, whatever switch, you need to have access port, and the device connected to the access port should be in that particular VLAN 10.
Very good, Veer. Very good. Right now, if you have verified the VLAN database, VLAN is there, trunk is configured, right? Then might be possible that VLAN 10 is not allowed on the trunk link.
Trunk port.
Yes. Now another question is, I have again two switch 1, switch 2. Here I have created VLAN 10 on switch number 1, and VTP is enabled on both the switch, VTP, but switch 1 is not propagating this VLAN information to switch 2. What can be the reason? Switch 1 is not propagating VLAN information to switch 2 through VTP dynamically. What can be the reason?
They are not in the same domain.
Okay, we can start with checking out whether the port is configured as trunk or not.
Okay, very good.
And
First you will verify that trunk is configured as trunk or not. Let's say I have verified that. Now I have configured the link as trunk. Okay.
okay, then we can check the domain name.
Check the domain name, sir.
Now you will check the domain name. Maybe
Yes.
domain name is not same. So
Yeah.
let's say I have checked domain name is same.
The switch is in transparent mode.
Version, also version number.
VTP version 1 and 2 was compatible with each other.
We'll check the switch to configuration.
VTP mode. We need to check. Yeah,
VTP mode.
it needs to be in server mode.
Yep.
It needs to be in server mode. It could be
Server
in
and
transparent mode.
Okay, let's say switch 1 is my server mode switch.
Server.
Next.
Client.
And this one is, let's say, client. Still switch 1 is not propagating VLAN information to switch 2.
Still not.
Maybe switch 2 doesn't have that VLAN, like any device in that VLAN. So
Revision
that
The
is why-
number is different. Version number is different.
One
Yeah,
minute,
revision number.
1 minute. Prague, what you were saying?
Yeah, so the second switch doesn't have any device configured in that VLAN, like
That is
So
the
that
not
is why-
requirement of VTP, sir.
in the last
That's the
class,
requirement of.
there is no device in that VLAN that we don't
To
need to
propagate the
broadcast that.
VLAN information, it is not required like the user must be there in the VLAN.
Okay, yeah.
You
That's
can
only
say,
for SVI.
you can say that on the trunk link makes your VLAN 10 is
Allow.
allowed, right? VLAN 10 should be allowed on the trunk link. Okay, so let's say I have checked that also. VLAN 10 is allowed here on the trunk link. Then also it is not propagating.
Check the
Then
revision
sir,
number.
if
The revision
password is
revision number
configured, then we can check if the
correct
password is
time.
matching.
VTP password.
Yes, it should be match.
VTP password should match. Very good, right? Okay, these are the criteria of VTP. Very good. Now you can troubleshoot if there is issue. Another question is, guys, tell me what is VTP pruning?
It stopped the
VTP pruning is
VLAN,
slow broadcasting
VLAN traffic,
message.
which is not required.
Stop
Stop the
unnecessary
or
VLAN traffic.
broadcast.
Unnecessary VLAN
stop
traffic
of VLAN.
to reach the switch.
Yes.
Where the VLAN is not
Multicast
available.
and unknown unicast traffic on trunk
Strong
link.
port.
Trunk link, right? And how switches are going to negotiate this information?
By the join message.
With the help of
Join.
join message. Very good. Absolutely right. Okay. Now let's start.
STP.
STP stand for
Spanning tree.
Spanning
Tree
tree
protocol.
spanning
protocol.
Tree protocol.
protocol. Very good. Guys, one thing here, important thing. STP. Before STP, we had discussed two functions of switch. One was address learning. One function was address learning. Switch learn source MAC address albase. Second function was forwarding based on destination MAC it take. Forwarding decision. And the third function of switch is
Loop avoidance.
And for the loop avoidance, switches use
STP.
by default it is
Enable.
enabled.
Enabled.
And STP is only required when we have redundant link in the network. So in my case here, is STP required? Is STP
No,
required?
no.
No, sir.
Yes.
But by default it is?
One
Enabled.
link.
Enabled. It's
By
enabled
default
by
it is
default.
enabled. If it is enabled, definitely switch is using some memory, CPU. It is using CPU for STP as well. So don't you think we should disable STP here?
Yes, yes.
Why by
It
default it
can be
is
this
enabled?
to avoid loop.
Like guys, why VTP is enabled? Because centralized VLAN database is very important in the network. Otherwise it might be possible one switch can drop the traffic in between source and destination.
It is enabled because by accidentally, if somebody, a cable is lying, without connectivity, and somebody thinks, okay, it should go somewhere, or somebody connects the cable into the switch, unknowingly, accidentally, they can create a loop.
Correct. Absolutely right. So loop is very dangerous in the network. My question to you is how loop can form in the network? Can anyone tell me if there is redundant link? Let's say let me draw one simple network here in front of you. Let's suppose this one. And here you can verify that STP is enabled or not by default. Command is show a spanning tree protocol. So a spanning tree. And you can see
Protocol.
STP is enabled for this is the instance for VLAN 1. Right now I think I have only one VLAN 1. So here is the STP instance for VLAN 1. There are so many things. Right now might be possible you are not able to understand what is breeze ID, what is root breeze ID, What is priority, address, route breeze, hello time, access time, forward delay time. We will learn these all things. Do not worry. But it is enabled. I am asking you how loop can form in the network if we have the redundant link. Let's suppose two switches are there, switch 1 and
Switch 2.
switch 2. Switch 1, switch 2. Is my screen visible?
Yes, sir.
Okay, great.
Yes.
Let's suppose two links are there. One is 0/0 and one is 0/1.
1.
Can anyone tell me how loop can form and what is the meaning of loop? What is loop?
Version mismatch, sir. Mac flapping.
So loop
Loop
traffic will
that
go
is
1 to
loop
2,
is
then 2 to
correct.
1, then again 1 to 2, 2 to 1, at less.
When a packet travels
Switch having the same MAC address
So,
from two different interfaces.
Very good. Someone said when switch learns same MAC address on multiple port, that is loop. That is also called MAC flapping. And MAC flapping is nothing but the loop only. Right? Now how loop can form? How can loop form in network? Guys, there are two types of loop, layer 2 loop and layer 3 loop. Right now I am talking about which loop?
layer 3.
Layer 2.
Layer 2.
I am talking about layer 2 loop. So what happened in case of unknown unicast flooding, or in case of broadcast message, whenever a user is going to generate gracious ARP or ARP message, right? Or in case of multicast traffic, there will be MAC flapping. You know how? Let me add one PC here. Let's say here I have add one PC. MAC address of this PC is A. And when I will configure IP address here 10.1.1.1, can anyone tell me what will happen behind the scene?
Gracious ARP.
It will generate gracious ARP. Correct? In the
That's
GRP,
right.
what will be the target IP? 10.1.1.1. Target IP, source IP 10.1.1.1. Source MAC A, target MAC 0, 0.0.0 unknown. After that, at layer 2 in the Ethernet handle, source MAC will be A and destination MAC will be what?
FFFF.
All F. This is my GRP message, gracious ARP message. So PC will forward it to switch. Switch is going to receive it on their port, and this port is in any VLAN, doesn't matter, right? VLAN 10, 20, 30, in any VLAN, 0/2. Now switch has received this GRP message on 0/0 interface. What switch 1 will do with this? It will learn.
It will learn the MAC address for the source.
It will learn the MAC address. Very good. You know both switches are going to maintain a MAC address table. In the MAC address table of switch 1 and switch 2, let me draw the MAC address table as well. This is MAC address table of switch 1.
Switch 1.
This is MAC address table of switch
2.
A port with MAC address.
Okay, wait a minute. MAC address table. MAC address table, and here also we have MAC address table. Table of switch 1 and switch 2. I'm assuming this user is in, let's say, VLAN
10.
10. This user is in VLAN 10. Just I have mentioned the VLAN as well to make the scenario more clear. Now, when switch is going to receive this GRP message on 0/2 interface, tell me what will happen behind the scene. All the step in detail. First, switch is going to
It's MAC address.
learn the MAC
Table.
address. The first function of switch, address learning. It will create one
Right.
entry in their database that on my 0/2
2
port,
port
a device is connected whose MAC address is
A
A,
A.
and in which VLAN?
VLAN
10.
10.
In VLAN 10. After that, second function, forwarding.
We'll check the
Forwarding the
forwarding.
For the forwarding, switch is going to check what?
Also,
Destination
it's
MAC.
MAC table.
Destination MAC. Destination MAC is broadcast. Switch will forward one copy from 0/0 as well as
1
It will also
Ports.
perform tagging as these link are trunk link. As these link are trunk link,
trunk
it will also perform tagging. It will add the
tagging.
VLAN 10 tag either by using .1q protocol or
ISL.
ISL protocol. Okay. Now, switch 2 is going to receive it on 2 ports. Let's say switch 2 have received it first on 0/0 port. What switch 2 will do? Again, 2 function, address learning. First it will learn
Yes, added to its MAC address table.
on 0/1 port a MAC address in which VLAN? In VLAN 10.
10.
And after that, switch 2 will forward it from. It will forward from
Second port.
second port, this port, right? Again, switch 1 is going to receive it. This time, switch 1 is going to learn a MAC address on which port and in which VLAN?
VLAN 10.
0/1 port, MAC address A, and VLAN
10.
10. Can switch learn same MAC address on multiple port? No. That is what? That is loop, guys. This is called loop. And what switch will do? Again, the second function of switch, forwarding. After learning a MAC address, again switch 1 is going to forward it from this interface. Again switch will learn and then forward it from this interface. Again it will be moving like this. And same thing will be happening in this direction as well. In both direction, your broadcast message will be flooding between switch 1 and switch 2, will be moving. And it will be moving for lifetime. There is no any TTL value like IP header. So the MAC address table of switch will be flapping. Soon switch is going to learn a MAC address on 0/1 port. Soon it will learn the same MAC address on 0/2. Again it will remove and learn on another port, again on another port, right? This particular thing is called MAC flapping. And in the production, if you are in front of device, you will see the LED of your ports will start blinking. LED of ports will start blinking, and
Blinking.
when you will see the LED is blinking quickly, it means there is
Looping.
it means there is loop. And the loop means same thing. The MAC flapping means it is learning the same MAC address on multiple port. Quickly it is changing. Even we can check it practically in the GNS3. See, I am going to take 2 switch here. Let's say this is my switch 1 and switch 2. I'm going to connect 2 cable here. If I'm going to connect 2 cable, if there is only one link between switch 1 and switch 2, then loop will never form, right? We know this.
That's right.
Can loop form then? No. See, if this is my scenario, when we have 2 ports, one is F0/0, one is 0/1. Sorry, 0/1 and 0/2. See, by default, STP is running. That's why STP has blocked one port. Which port? 0/2 port. 0/2 port is blocked. In the STP, we will learn how switch will decide which port should be in standby state, which port should be in active state. The route bridge election, the port election, everything we are going to learn. But as STP is by default enabled, that's why it has blocked one port. Can loop form here? Can loop form?
No.
Loop cannot form because only one port is active between switch 1 and switch 2. One port is in blocking state. But guys, if I'm going to disable the STP from switch number 2, if I'm going to say no spanning tree protocol config t, and by default this command is running a spanning tree for VLAN 1. If I'm going to say no to this command, what will happen? Now you can see both port of switch number 2 is up, active, green. Now one port on switch number 1 is blocked. If I will disable STP from switch number 1 also, then both link will be up. Go to switch 1 and say no spanning tree for VLAN 1, and as soon as I have disabled the spanning tree, you can see now both ports are in active state, correct?
Yes, sir.
And now if I'm going to configure the IP address here on the PC, not only in the gracious ARP scenario guys, in case of ARP, in case of a non-unique passwording, when switch don't know the MAC address of destination device, if they are not able to find the port in their MAC address table, every time there will be loop MAC flapping. Let me show you IP 10.1.1.1, and before assigning this IP address, I'm going to open the simulation mode, right, just to show you the loop. See, LEDs just started blinking. Are you able to see?
Yes,
Yes,
sir.
sir.
That means what? That means there is loop. Now let me show you the MAC address of this PC. MAC address of this PC is this one. Let me copy it. Let me take you to switch 1, and let me show you the MAC address table of switch 1. So MAC address table,
Address table.
and here in the packet tracer we cannot filter dynamic, and we cannot filter, but you can see this was my MAC address of PC1. It has learned this MAC address on which port?
Yeah,
Yeah,
0
0
to
0/2 port.
Yes,
yes,
sir.
sir.
Now
0/0.
0/1.
this is what?
Looping.
Loop.
MAC
Different
flapping
ports for
over.
MAC
or
address.
loop.
Same MAC address port.
Now 0/2,
Have 0/2 again.
right? So it is learning the MAC address sometime on 0/1, then quickly 0/2. Even it is changing the MAC address very quickly, very fast, right? Even you can not check each and every change in the table, because when you are going to run command, it takes some time. In that time it is going to flap 10 times. So at this particular time, when any user are going to communicate, any user are going to forward the traffic, might be possible switch will drop the traffic, right? Because the CPU utilization of your devices will reach to
Maximum.
maximum, and you know, when the CPU utilization will reach to 90%, 95%, my devices will start hanging. And if your device will hang, then you know what will happen. My side will goes down, correct?
Yes,
That's why I'm
sir.
saying it is
Yes.
so dangerous. See, if I am going to remove the IP here from the port, say DHCP and static, it is even not getting a stable, right? Now user has not generated any message. User has not generated any message this time. The earlier message is even moving between switch 1 and switch 2. Earlier this PC was PC had generated one GRP, and that message is still moving between switch 1 and switch 2. It will be moving for lifetime until and unless you will note down any port. Whenever you will see loop in the network, the first thing before enabling STP or troubleshooting the issues, you will down the redundant link. See, as soon as I have done, my topology is now stable. Again, say no set up, again you can see interface range F0/122 set down. No, shut down. Clear. Loop is very dangerous. Even layer 3 loop is fine for a minute, like because there is TTL. TTL value is what? 255. That means after 255 routers, TTL will become 0 and router will discard the traffic packet. But layer 2 loop is so dangerous for network. This is never ending loop. That's why it's a recommendation to not turn off
STP.
STP protocol. Here on the PC, if I'm going to configure IP again 20.1.1 in the simulation mode, and you can play. It will be moving always, right? Switch is receiving broadcast message on port 1, it is forwarding from port 2. Again, when switch 2 will receive on port 2, it will forward from port 1. Whenever we have redundant link in the network, STP must be enabled, and make sure STP is configured properly, right? Sometime STP is enabled, then also you will find loop. You will see loop in the network. Why? Maybe my STP is not configured properly. So I'm going to enable STP now for VLAN 1, and here also for VLAN 1, spanning tree VLAN 1. Now STP doesn't matter how many links are there between switch 1 and switch 2. STP will only allow one link at a time, right? Maybe you have 100 number of link, but only one link will use to forward the data. Hope it is clear.
Sir, I have a question.
Go ahead.
Instead of having two separate links as a trunk between two switches, can we combine those in ether channel?
Yes, you can combine.
And we don't need STP, right? If we do that,
We need STP
because
then also.
the STP will count that as one single logical.
Correct.
Okay. Yeah.
Anything else?
Sir, what happen if the loop is happen on the same switch? For example, in switch 1, if
On both.
the port number.
No, switch will not, like loop will not form on one switch. Loop will always form between the
Uh,
switches.
Suppose sir, there is a only single switch and single PC connected to it. And what if one cable is connected to port number 5, then again it's connected to port number 6?
Then it can form the loop.
Okay, that is what is my question is. Someone is by mistake same cable connected to the same switch, then also.
Yeah, that happens
No.
sometime in the production as well.
So mostly happens at this.
Yeah.
Sir, one more question. Now with the new data centers, we are moving from 3-layer architecture to 2-layer architecture, where we have spine and leaf, and STP and ISIS is already by default running behind the scene. We don't have to configure or look into it. Is that correct?
Yes.
So the importance of can we say that importance of STP is not very subsequent in the coming technologies, new technology data center?
It is still required there as well. See, we are combining their multiple link into single logical link, the ether channel, VSS. We are using VSS technology there. Whenever you have redundant link over switch, any switch, 2-tier, 3-tier, Doesn't matter. Loop can form. There is chance of loop.
Loop.
Now, STP is by default enabled. It is running. Even it is working properly. Then why we need to learn it? If it is by default working, then why we are going to learn the STP protocol? By default enable, it is working fine. You see, already it has blocked one port. Why we are going to learn it?
Because there are different modes of STP, and depending on the architecture, we can utilize different types, whatever is best suitable for the network, and also to troubleshoot in case accidentally if there is a loop.
Okay.
Also find the a better path for the data transfer.
Guys, understand, let's say in the company I have 4 switches, 4 floors. At each floor I have one switch. These switches can be one physical switch or multiple physical switch combined in single logical switch with the help of stacking. That might be possible, but at each floor we have one switch, physical or logical, either physical, either logical, connected like this. These switches are connected like this, and this, this. On switch number 1, switch number 2, switch number 3, and switch number 4. Here I have one user in VLAN 10, one user in VLAN 20. Here also one user in VLAN 10 and one user in VLAN 20. VLAN 10 user, VLAN 20 user, VLAN 10 user, VLAN 20 user. You tell me, one VLAN 10 user want to communicate with other VLAN 10 user, PC1 to PC2. This is PC1 and this is PC2. Tell me how they should forward the traffic, like which path will be the best path between PC1 and PC2?
Sir, they will take the BPDU cards, no, sir?
Direct
This
link between
Switch 2.
Direct path.
PC1 to switch 1, switch 1 to switch 2, switch 2 to PC2. But if you will leave the STP configuration on default, then might be possible that your traffic is going to switch 1, then switch 1 will forward it to switch 3, switch 3 will forward it to switch 4, switch 4 will forward it to switch 2, and then switch 2 will forward it to PC2. This is longest path, correct?
Yes, sir.
So if you have the knowledge of switching, you can optimize the performance. If switches between switches, if it is going to use the shortest path, there will be less latency. Am I right? So even STP is by default enabled, so that loop can not form in the network. But when it's come to network designing configuration from the scratch, based on our requirement, we will optimize the performance, and according to that we will set up the STP configuration, right? There are so many things which we need to learn here, like which switch will become root bridge, or might be possible that, see, there is some user in VLAN 30 here, one user in VLAN 30, one user in VLAN 30. So these VLAN 30 users should communicate via switch 3 and 4 directly. Traffic should not go via switch 1 or switch 2 for VLAN 30 users. For VLAN 10 users, traffic should go via switch 1 and switch 2. So these kinds of optimization is required in the production, right? And another thing, out of 4 switches, 1 switch will become root bridge. By default, STP will select root bridge switch based on lowest MAC address. But do you think a switch should check the best switch or master switch based on MAC address? Is it the right thing? Should switch become master switch based on their MAC address? No, MAC address is what? The vendor assigned address. If I am going to make any switch master switch, let's say switch 1, I will take care about their CPU. Definitely, this switch is going to use more CPU because it is managing the STP domain. Similar like VTP server mode switch. If I am going to say here, your server mode switch, like which switch will be your server mode switch in the VTP, that will be decided on the MAC address. Is it a good thing?
No.
No. Switches should never become the best switch or master switch based on their MAC address. MAC address is not assigned by us. MAC address is assigned by vendors. So how you can change the root bridge, or how you can make the root bridge switch or master switch based on your requirement? You can only configure if you have the knowledge of STP. Another thing, whenever there is loop, you can troubleshoot it. First optimize, troubleshoot, right? And management, the configuration, which should be switch should be my root bridge switch. Here also, like let's say the bandwidth of upper link is 100 Mbps and bandwidth of lower link is 200 Mbps. So which port should be my, which link should be in active state by default? 0/0, 0/1.
0/1.
0/1. But by default, STP might be STP. Based on STP, 0/0 is going to be active port, because STP select best link on the basis of port ID. The lower port ID means active link. So you are going to learn it so that you can configure the STP based on your needs, based on your scenario. You can optimize the performance. Many times I told you the performance optimization is one of the most important task of network engineer. You have to always take care about your CPU performance. Make sure users are not experiencing any delay to access the application, to access the internet. And even nowadays we are deploying our applications on cloud. So in that case, we have to optimize the performance. And this is the reason why you are going to master it. And these all are the component of STP which you need to learn. First thing is what?
Says root ID.
Root ID. Second thing?
Bridge ID.
Bridge ID. And see guys, root ID is nothing but the combination of two things: priority plus base
MAC address.
Base MAC address. Right? How you will find the base MAC address of switch? In version. If you are going to run command show version, you can check the base MAC address somewhere. Is anyone able to see the base MAC address? In last it's B7. So switch is going to use this base MAC address for root bridge election. So a spanning tree. See the bridge ID, it is using the same MAC address, correct? And the priority.
Yeah.
By default, priority on switches is same. By default, priority on switches is same. So in this case, if MAC address, base MAC address of switch 1 is 0A, base MAC address of switch 2 is 0B, base MAC address of switch number 3 0C, and base MAC address of switch 4 is
0D.
0D. And priority is by default same, 32768. 32768. You have seen here 9. You have seen 32769. 9. I am saying 8.
9.
So actually, you know which protocol is running here. Not STP, not common spanning. Right now we are running common spanning tree protocol. But which version of STP is running on the switch? So a spanning tree summary. Here you can check. Switch is in which mode?
Bridge.
PVST mode.
Or PVST mode.
Per VLAN spanning tree, right? So just it had added the VLAN ID in their priority. By default priority was
PVST.
32768 and plus 1. So it became, if I am going to create VLAN 10 here, VLAN 10, and now if I will show you the spanning tree, you can see switch has single instance, only VLAN 10. Why we don't have VLAN 20 instance? So VLAN brief, we have the VLAN 10 in VLAN database. A spanning tree for VLAN 10, and so a spanning tree. No, right? Let me configure the link as a trunk interface E0/1 switch port mode trunk switch port, sorry, interface F0/1 and switch port mode trunk, and so a spanning tree. Now you can see we have instance for VLAN 1 as well as for VLAN 10. And what is the priority here? 3276, not 7. 32778, not 6. It has added the VLAN ID in the priority. Priority was 32768 plus 10. So it became 7, 8. And see, until and unless there was no any port in VLAN 10, it was not maintaining VLAN 10 STP instance. Concept is similar like your SVI. Until and unless there is no any port in VLAN 10, it will not maintain VLAN 10 STP instance. As soon as I have created the trunk link, I have configured the trunk link, it has started maintaining STP instance for VLAN 10 as well. So a spanning tree VLAN 10. Like this you can check STP instance. Clear? So by default priority is same, 32768. Here also 32768, 32768 and 32768. 32768. So by default, which switch will become root bridge switch? Priority is tie. To select root bridge in the STP, guys, first of all, before root bridge, understand one more thing. In the STP, all the switches are going to calculate their bridge ID, right? Bridge ID. What I told you, what is bridge ID? Bridge ID is combination of two things. Priority plus their MAC address 32768 plus 0A is the bridge ID of switch 1. Bridge ID of switch 2 will be what?
32768 plus 0B.
32768 plus 0B. Bridge ID of switch 3?
32768 plus 0C.
32768 plus 0C. And switch 4? Again 32768 plus 0D. The switch who has lowest bridge ID will become root bridge switch.
Root bridge.
Will become root bridge switch. What is root bridge switch? Root bridge is the master switch for now. For now, root bridge switch is the master switch who is going to manage the entire STP domain. Manage means the root bridge switch will decide which port will be in blocking state, which port will be in forwarding state. Root bridge switch will decide which path will be the best path to forward the traffic. That's why I'm saying master switch in simple word. So in my scenario, which switch will become the master switch? The switch which has lowest bridge ID. So tell me which switch has the lowest bridge ID, guys?
Switch 1.
Switch 1 has the lowest bridge ID. So switch 1 will become root bridge, right? So on any switch, like on switch number 4, if you will check a spanning tree protocol, so a spanning tree protocol, you will find both the things, root bridge ID, root bridge ID, as well as bridge ID. What will be the root bridge ID on switch number 4? Who is their root bridge? 32768 plus 0 A. Switch 1 bridge ID. Switch 1 bridge ID is the root bridge ID because switch 1 is my root bridge switch, and their bridge ID will be what? 32768 plus 0 D, their own ID. On switch number 1, root bridge ID as well as bridge ID both will be same. Root bridge ID and bridge ID both will be same. 32768 plus 0
A.
A. On any switch you will see root bridge ID is switch 1 bridge ID. All the switches are going to calculate their bridge ID, and the switch which has lowest bridge ID will become root bridge, and all other switch means non-root bridge switch. Now switch 1 is my root bridge switch, and switch 2, 3 and 4 are non-root bridge switch. This is root bridge switch, and rest all the switches are non-root bridge switch. In short you can say RB as well. RB, root bridge. Switch 2, non-root bridge switch. So two things you need to identify in the STP domain here in in the EVNG or in packet tracer, you will find that. See their bridge ID and root bridge ID. Is bridge ID and root bridge ID matching? Same.
Yes.
If it is same, then this switch is the
Master.
master switch, root switch. On switch number 2, if I will take you on switch 2, on switch number 2, see, here is my switch 2, enable and show a spanning tree. See, their bridge ID is unique, correct? Their bridge ID is different, not the same, but root bridge ID is the same. This is nothing but the bridge ID of switch 1. It means what? It means both the switches are in same STP domain. What it mean? It mean both the switches are in same STP domain. Guys, here just I'm going to show you one troubleshooting, and I have faced these kind of issues many times in the production. On switch number 1, interface E1/0. This link should be trunk link. Interface E1/0. Switch port trunk encapsulation.1q and switch port mode trunk. Switch port allowed. Switch port trunk allowed VLAN. I'm saying 1 and 10. 1 and 10 VLAN. These two VLANs are allowed on the trunk link. Do so history. I'm going to copy and paste this command on switch number 2 as well. Copy, go to switch 2, and only these two VLANs are allowed on trunk link. All good. Now on switch number 1, I'm going to put one port in VLAN 20 so that it will start maintaining STP instance for VLAN 20 as well. Interface E0/2, switch port access VLAN 20, and so VLAN brief VLAN 20 is already there, right? So a spanning tree VLAN 20, it has maintained one STP instance for VLAN 20 as well. Similarly on switch number 2 also I will do same thing. Go to switch 2 and interface E0/0. I'm saying switch port access VLAN 20 and do so spanning tree for VLAN 20 STP instance. See guys, STP instance 4 VLAN 20 on switch number 1, STP instance 4 VLAN 20 on switch number 2. Is root bridge ID matching? Both switches are saying what? I am the
Root bridge.
I'm the root bridge. This is the issue. Here there is chance that loop can form because both switch 1 and switch 2 are not in same STP domain. Are not in same. For VLAN 10, if I will show you the STP instance for VLAN 10 and on switch number 2 also for VLAN 10, you can see root bridge ID is same or not? Same or not? Same. Means both the switches are in same STP domain. But for VLAN 20, both are in different STP domain. Why both are in different STP domain? Can anyone tell me? Can anyone tell me? Can anyone tell me why both switches, switch 1 is also saying I am the root bridge and switch 2 is also saying I am the root bridge for VLAN
Root bridge.
20, right? There are two prime minister in India. Why? If there
Because
are
there
two,
is no loop.
Since we only allow VLAN 1 and 10 on the trunk
because
port.
because on the trunk link VLAN 20 traffic are not allowed. Switch 1 cannot share their root bridge ID to switch 2 for VLAN 20. Similarly, switch 2 can also not share their bridge ID to switch 1 in VLAN 20 as VLAN 20 traffic is not allowed over here. Am I right? So switch 1 don't know that bridge ID of switch 2 and switch 2 don't know about the bridge ID of switch 1. So that's why both has elected their self as root bridge. In your topology, there should be only one root bridge. Right? If there are two PM in the India, it means what? Both PM don't know about each other, correct? Modi and Yogi, if both are the prime minister, it mean what? It mean they don't know that Modi ji don't know hey Yogi is already the prime minister of this country and Yogi don't know Modi is already prime minister of this country. There is no any communication between these two PM. Same thing is happening over here. That is issue for you in the network. What is that? That is issue. Make sure root bridge ID on all the switches is same. It means all the switches are in same STP domain. Similarly for VTP as well, guys. Switch 1, switch 2 and switch 3. Here domain name is Cisco. Here also domain name is Cisco and here domain name is CCNA. That means this switch is in different VTP domain and these switches are in different VTP domain. If I am going to create VLAN 10 here, that will be propagated to this switch but not to this switch. Even if this switch 2 will propagate to switch number 3, it will not accept, it will not create VLAN 10 because this switch is not the part of this VTP domain. There are two VTP domain. So your VLAN database will be flooded within the VTP domain, correct? Similarly, STP message will be flooded within the STP domain. And what is the STP message, Praful? That is STP hello message. BPDU. Yes, you can ask.
So when we configure the domain name, the single domain name will work for BTP and STP, right? We don't have to configure two separates. Right.
Domain names. If domain name on all the switches is same, it mean what? It mean all switches belongs to same VTP domain. It might be possible sometime you will have multiple domain, VTP domain. In the large organization, might be possible we have two VTP domain. There are two server mode switch. We are managing VLAN database separately. right? For an example, in the campus, there are 4 buildings. 2 buildings are in one VTP domain and rest 2 buildings are in another VTP domain, right? There is another engineer who is managing the VLAN of this domain and another engineer is managing, or same engineer is managing, that doesn't matter. But we have 2 VTP domain. Even all switches are connected together. They are able to communicate, able to exchange the data, but their VLAN propagation, VLAN management is different.
So how do we configure 2 different domain on single switch? Are we just
Not on single switch, brother, on different switch. Here I will configure domain name CCNA on these 2 switches, and here I will configure Cisco. Right? When the switches will see my domain name Cisco, my domain name Cisco, that means we both belongs to same domain. My domain name CCNA, my domain name CCNA, we both belongs to same domain. When any VTP message will come from this domain, it will check domain name was Cisco, my domain name is CCNA, that means we are not from the same domain. I will not update my VLAN database based on your message, where your update, it is like that. Now,
thank you.
Till now we have only talked about the basic about STP loop and the protocol. That protocol is enabled. Let's understand now some terminology of a spanning tree protocol. STP is the height of switching. Terminology. There are some terminology, guys. First one is root bridge. Second one is first thing. Second component of STP is
bridge ID, sir.
Okay, bridge ID. Let me keep this over here at first position. And this one here. Bridge ID and then root bridge ID. Third thing, BPDU. BPDU is nothing but the STP message. Like in the VTP, how many messages was there? In the VTP, how many messages are there?
4.
There are 4 messages.
4 messages. Can you tell me the name of all?
Summary advertisements.
Okay.
Summary.
Subset advertisement.
Subset advertisements.
Okay.
Subset request.
Okay.
And
BTP join message.
the last will be a join message.
In STP we have single message. Single message, that is called
hello, I think.
BPDU. Right? You can also say the hello message. What we call it? BPDU. BPDU stands for Bridge Protocol Data Unit. Bridge Protocol Data Unit. When you will understand the content of BPDU message, like what information will be there in the BPDU message, that will be the 30% of STP. 30% of STP is, it means 30% of STP is clear to you. Third component. Fourth component is what? Fourth component.
So BPDU filtering.
Path cost. Path cost is used to, like path cost means the best path. Best path to reach root bridge. That is called path cost. The fifth component is
Port types.
Root port. Next component, designated port. Next component, blocking port or alternate port. There are three types of port in STP: root port, designated port, and alternate port. The status of root port and designated port will be forwarding, and the status of alternate port will be blocking, right? So the port which will become alternate, I am so sorry for that port, that will be always in blocking state. Switch will not forward any data from that port. Switch can only receive the BPDU on alternate port. That's it. Not user data. User data can be forwarded from the alternate port and designated port. These are the terminology of STP. Let's understand all one by one. Let's start from breeze ID. Breeze ID. Yeah. Who will tell me what is breeze ID?
It is a combination of MAC address and priority.
Okay, great. Anything else?
Lowest priority will be preferred for the bridge.
Okay, great. Anything else?
By default value is 32768.
Great, that is priority. Okay, tell me guys, what's about other?
Every switch has its own bridge ID.
Unique identifier of each and every switches in your switching or layer 2 network. Unique identifier of each and every switch in the layer 2 network. It's used to elect the root bridge. Used to elect the root bridge, which is nothing but the master switch.
Sir,
Which is the,
can you write the notepad, sir?
okay, which is the central point of a spanning tree, or central management point, or we can say master switch, which is the master switch in STP domain. And breeze ID is a 2 bytes priority value and what is the length of MAC address?
6 bytes.
48.
No.
6 bytes, 48 bits.
And 6 bytes
48.
MAC address, or you can say base MAC address. So what will be the total length of breeze ID?
8 bytes.
Total length will be 8 bytes. What will be the range of priority?
32768.
32768. That is the default priority. I'm talking about the range 0 to 2 power 16, right? It is 16 bits. Priority is 2 byte, means 16 bits, correct?
Yeah.
8 bits is called 1 byte. So 2 bytes means 16 bits. So range can be 0 to 2 power 16. Range of priority is going to be 0 to, total we have how many priority? 655, 3, 5. So range will be what? 6. Range will be what? 0 to 6, 5, 3, 5. This is the range of priority, and by default priority is
326,
default is
3266.
3276
8.
8. These are very important for STP types, or to understand other types of STP. Right now we are learning CST. CST stands for Common Spanning Tree Protocol. On other vendors, STP works like this only.
Sir, what is the MAC address of the? We know that the MAC address is assigned to the port. What will be the MAC address of the switch?
All the switches will have one base MAC address. Right? When you create SVI on the switch, switch create virtual MAC based on their base MAC address. So all the switches has one NIC, guys. All the switches has one NIC, one inbuilt MAC address, that is called base MAC address of
Base MAC address.
switch. So
Switch.
I'm talking about the base MAC address. Bridge ID is combination of two things, is 2 bytes priority value and 6 bytes MAC address. So total length of bridge ID is going to be 8 bytes. Means 8 byte means how many bits?
64.
64 bits. Hope it is clear. Is it clear? Bridge ID.
Yes, yes.
Yes, sir.
Okay.
Bridge ID is the unique identifier of each and every switch in STP domain or layer 2 network. After that, it is used to elect root bridge in the layer 2 network. And root bridge ID is combination of two things, 2 bytes priority plus 6 bytes MAC address. Next thing is,
Sir, here we have one small doubt.
yeah, go ahead, go ahead.
Now, why we should use default priority as a 32768? Is there any reason?
Brother, why by default STP is enabled?
We avoid loops in the
Loop,
switch network.
right? And to avoid the loop, one switch have to become root bridge. And to elect root bridge, switches have to create elect what? Bridge ID. Have to calculate the bridge ID. How they will elect the bridge ID? MAC address is already there. They have to configure what? Priority. So the priority is configured by default on the switches, on all the switches. You can change it. And why they have choose this number only as a default value? You will understand that as well when you will understand the entire STP protocol. For now, if you want to change it, there is command to change. There is command not able to access. We can change the default priority. Now next thing is, guys, what is root bridge ID? So who will explain the root bridge ID? Root bridge ID is also 8 bytes information, the same thing, 2 byte priority plus 8 byte.
MAC address.
MAC address. But what it is, what root bridge exactly is?
Is the root bridge of the master switch. Root bridge ID of the master switch.
It is nothing but the
Is nothing like a bridge ID of the master.
a switch A
Having the
switch
lowest.
which has
the lowest bridge ID.
has the best or lowest. When I am saying best, it means I am talking about lowest. Bridge ID. Switch which has the best or lowest bridge ID. Best means lowest. Either you can say lowest or you can say best. Again, it is combination of MAC address and
Priority.
Priority.
priority. And this switch, root P switch, is a reference point or the central point for all other switches in the network when determining the redundant path, like which path will be in blocking state, which path will be in active state, that will be elected by my root bridge. It is reference point or master switch in my STP domain. Clear, sir? There is not much difference between bridge ID and root bridge ID, right? Both are same, but the switch which has the lowest bridge ID, that switch will become my root bridge, and root bridge ID is nothing but the bridge ID of that switch who has lowest bridge ID. Next thing is BPDU, most important thing in the STP. What is BPDU? BPDU is
It is a generating message. Hello message.
you know
It is a
root
message.
bridge 1 minute. Root bridge always generates a hello message after every 2 seconds. Root bridge always generate a message, STP message after every 2 seconds, like hello message, and that message is
BPD.
called BPDU message. It is used to elect root bridge. It is used to elect root bridge. Now understand, if I have to switch, switch 1 and switch 2. MAC address of switch 1 is 0A. MAC address of switch 2 is 0B. Priority is 32768. Here also 32768. And here is one link, trunk link. Now how root bridge election will happen here? When switches will come up, when you will configure the link as a trunk link, both switch will think I am the I am the
root
bridge. I am the root. Both switches. And as switch will become root bridge, switch will start sending what?
BPDU.
BPDU. Switch 1 will also share BPDU. Switch 2 will also share BPDU. Soon I am going to talk about the content in BPDU. What will be the information inside BPDU? But one information is bridge ID. One information is what, guys? Bridge ID. So
Bridge
the
ID.
BPDU of switch 1 will carry their bridge ID 32768 plus 0A, and switch 2 BPDU will also carry their bridge ID 32768 plus 0B.
B.
When switch 2 will receive BPDU of switch 1, when switch 2 will receive BPDU of switch 1, it will get to know that I am not the
Master.
root bridge.
A root bridge.
Right? Because my bridge ID is 32768 and the bridge ID of switch 1 is lower than me. You know, let's understand two messages in the BPDU. First is bridge ID and second one is root bridge ID. Both will say my bridge ID is what? 32768 plus 0A. My root bridge ID and bridge ID both are same because both are thinking I am the root bridge 32768 plus 0B. Both are saying I am the root bridge. One is root bridge, one is bridge ID. But when switch 2 will receive the BPDU of switch 1, it will get to know that I am not the root bridge, and then switch 2 will stop generating BPDU.
BPDU message.
After that, it will not generate any BPDU
message.
Yes, hello message. And in their instance, STP instance, earlier the root bridge ID and their bridge ID both was what? Both was 32768 plus 0A, and bridge ID was also 32768 plus 0. Sorry, not AB. Earlier it was B. And now it is going to change their bridge ID. Bridge ID will become 0A. Right now, for switch number 2, root bridge is switch 1. And now switch 2 is going to calculate the best path to reach root bridge, that is path cost. Right now we have single link. So this path will become the best path. When we have the redundant path, multiple path, then it is going to select one path, one best path to reach their root bridge. Let's talk more about BPDU. After that, again I will come here. BPDU. It is used to elect root bridge. Let's understand the content of BPDU. Content of BPDU. So what I told you, one information is going to be what?
Bridge ID.
Bridge ID. And guys, there are two types of BPDU. Later you will learn that as well. One is configuration BPDU, another one is TCN BPDU. Right now I'm talking about configuration BPDU. TCN means topology change notification. Whenever any change will occur, at that time my root bridge switch or non-root bridge switch can generate TCN BPDU. But configuration BPDU will be generated by root bridge switch only. Why first time both switches have generated the configuration BPDU? Because both switch was thinking I am the root bridge. Right? In the content there will be protocol ID, but we are not going to discuss this protocol ID. It is similar like the in the IPv4 header you have seen version, right? Some other fields. So these are like that, no use for us. There will be version information also. Type will be there. In the type field, the types of message, it is configuration BPDU, config BPDU, or it is TCN BPDU. Which type of BPDU? It is BPDU. So type of message is important. That's why I have mentioned here. Okay.
It's TCP BPDU.
Which type of BPDU it is, that information will be there. Configuration BPDU or TCN BPDU. This is configuration BPDU. Okay. In the type field. Then flag field is here. Flags, right? We have total 8 flags. 8 bits for flags. Later we will talk about these all flags like TC flag, TCAC flag, and the rest 6 flags are not in use in the CST. We'll use that in our PVST, Rapid Explanatory Protocol, which we are using nowadays. We are not using CST protocol. Which protocol we are using? RSTP, Rapid Explanatory Protocol. So again, about the flag we'll talk later. The important field is this one, root, bridge, ID. There will be in the BPDU, in every BPDU, root bridge ID information will be there. And then cost will be there, cost value. What is the cost? So when root bridge will generate the BPDU, then cost will be what always? 0. What is the cost to reach root bridge from the root bridge? This cost is nothing
0.
but the cost to reach root bridge. This is also called root path cost. So root bridge always generate BPDU with cost 0. Cost to reach root bridge from root bridge will be always 0. From switch number 2, cost to reach root bridge can be any value. We'll see that how it will calculate the cost. Other information will be the designated bridge ID. Designated bridge ID, or you can say sender bridge ID, both are same. Sender bridge ID. Next information will be designated port ID or sender port ID. Designated or sender port ID. Next information will be what? Max edge time. Max edge time. These all are very important. Then forward delay time. Forward delay time, and then hello time. That's it. Hello time, which is 2 seconds by default. 2 seconds by default. These are the information content of BPDU. I want you to take a screenshot of this. Just take a screenshot of this. And one more thing, what it will, root bridge will always generate BPDU with cost 0. Root bridge always generates BPDU with cost 0. And non-root bridge switch getting noise. Please put yourself on mute. Non-root bridge switch will add cost of their receiving interface. Now you can take a screenshot of this page. Just take a screenshot. STP is important protocol, and this one is the most important part of STP to understand STP. Now here just I want to discuss one more thing, then I will give you the example, that is STP port ID. What is STP port ID? Because here I have told you that in the BPDU content you can see sender port ID, correct? So what is STP port ID, Praful? Port ID is combination of two things. STP port ID is combination of two things. Priority, port priority plus interface ID, and port priority is by default priority. This time I'm not talking about the priority of switch. I'm talking about the priority of port. Port priority plus interface ID. By default port priority is 128. So if I have one interface, let's say F0/0, F0/0 is interface ID. So F0/0 interface will get what? Priority, port ID will be what? 128.0. 0/1 will get STP port ID can be 128.1. 0/2 port number 2 can have STP port ID 128.2. Here in the STP you can verify that as well. So a spanning tree, and you can see the port ID of 0/0 is what? 128.1. It is considering this port as port 1, 2, 3, 4 like that. Okay, so you can see the port number, port ID in the STP. What is type? P2P. Sometime you will see shared, sometime you will see port to port. We'll see that. And state you can see forwarding, and role you can see port are designated port. Now let me give you one example here. Let's say I have 3 switches. Switch 1, and after that from here we'll continue tomorrow after this example. Switch 1, switch 2 and switch 3. Understand it guys very carefully. Cost, interface cost is nothing but the, see, STP never reveal the formula to calculate the cost of interface, how they have calculated the cost, but you will see the cost is inversely proportional to bandwidth. High bandwidth means low cost, and low cost will be always preferred, right? For fast Ethernet, what is the cost? See on the Ethernet link, what is the cost? How I can check cost?
100.
Here it is 100. On this is for Ethernet. On the Ethernet link, cost is 100. On the fast Ethernet link, what is the cost? Here you can check that. Here we have fast Ethernet link.
Be 10.
So a spanning tree. Cost is 19. Right? So fast Ethernet link has more bandwidth, less cost. Now what formula it has used to calculate this? I also don't know that, and I think STP even it has not revealed, right? But it is inversely proportional. Just you have to know, you should have knowledge about the cost for different types of link, like for Ethernet, fast Ethernet link, gig, 10 gig, 100 gig, okay, like that. So more bandwidth means low cost and lower value will be always preferred. Now this is switch 1, switch 2, switch 3. MAC address of switch 1 is again 0A. 0A. MAC address of switch 2 is again 0B, and MAC address of switch 3 is 0C. Even STP is not required here, but just to make you understand the topic, 0B, here it is 0B and this is 0C. To make you understand the STP, just I am taking this example. Okay. Now by default priority, you know this 32768. Guys, what will be the breeze ID?
32768 plus 0A.
Breeze ID will be 32768 plus 0A.
Plus 0A.
And root breeze ID
will be the same.
Root bridge ID will be also same 32768 plus 0
A.
A. Switch number by default switch 2 will think I am the also root bridge, switch 3 will also think I am the root bridge. All are going to send BPDU of each other. And then switch 2 and switch 3. When switch 2 and switch 3 will receive BPDU of switch 1, it will get to know that I am not the
root bridge.
Root bridge. Now see, when switch 1 will generate their BPDU. BPDU, this is the BPDU of switch 1. BPDU. What will be the information inside this BPDU?
Bridge ID.
Bridge ID. Bridge ID will be what?
32768 plus 0A.
768 plus 0A. Okay. Then the root bridge ID. First information will be what? Root bridge ID.
Root bridge ID.
Then cost. Cost will be what?
Cost will be
0.
100 or
0.
Yeah.
Cost to reach root bridge. This is root path cost. Then designated bridge ID or sender bridge ID. Sender bridge ID will be what? Same 32768 plus 0 A. Then designated port ID. Port ID.
Port ID would be
128 plus dot 1. I'm assuming this is port number 1. Port 1. Right. This is the BPDU. Switch 1 is going to share it to switch number 2. When switch 2 will receive this BPDU, switch 2 will get to know that root bridge ID is root bridge ID, or like this I can write root bridge ID is 32768 plus 0A. Sender bridge ID is designated bridge ID. They are on bridge ID.
Yep.
They're
So
on
the
bridge
port
ID
ID.
32.
What did that 128 came from on port ID? Is that by default? Or?
By default
Oh, that's
port priority.
Okay, by default port priority.
It has updated their STP instance. And now switch 2 is going to calculate cost. Cost of this interface is, let's say 19. This is fast Ethernet link. Cost is 19. 19. And
19.
Right. So now switch 2 is going to flood this information, the BPDU of switch 1 to switch number 3. Switch number 3. But switch 2 will modify something like sender bridge ID. Now switch 2 is sending it. See, in the BPDUs, some value will be changed on switch number 2. Root bridge ID will be same. Root bridge ID is going to be 32768 plus 0A. Cost will become what here? 19. Designated or sender bridge ID will become what? 32768 plus 0B.
0B.
And designated port ID? Port ID 128 dot, let's say 2. This is port number 2. BPDU, the BPDU of root bridge on switch number 2. Now the switch 2 is going to send it to switch 3. Switch 3 will receive on this interface. Again, switch 3 is going to update their STP database. Root bridge ID will be same. 32768 plus 0A. Bridge ID is going to be 32768 plus 0C. And here root bridge ID again 32768 plus 0A. And cost will become what here? 19 plus
19 plus 98. 19.
Right, so it will become
38.
And if switch 3 is connected with another switch, here designated bridge ID will become 32768 plus 0C, and sender port ID, designated port ID will be 128.2 or 3, any value. like this STP BPDU work. These are the content of BPDU, and then we will have Ethernet header here. In the Ethernet header, source MAC will be the MAC address of switch 1, destination MAC, multicast. The same multicast which we had seen in the VTP, DTP, CDP. Is it clear, guys? Now, let me ask you one question. Question is, this is 30% STP. How to identify superior BPDU? Superior BPDU means best BPDU. Now I have one switch here. This switch is receiving BPDU from two different switch 1, right? It is receiving BPDU on their two interfaces. Let's say port number 1 and port number 2, or E0/0 and E0/1. Right? This switch need to identify that I am receiving best BPDU on which port. The port which is receiving best BPDU will be in forwarding state, and other port will be in blocking. All ports will be in blocking state. Right? So to identify the superior BPDU, first switch is going to check root bridge ID. First it will check what?
Root bridge ID.
Root bridge ID. Root bridge ID. Let's say root bridge ID over here is 32768 plus 0A, and root bridge ID on this interface is 32768 plus 0B. So where it is receiving superior BPDU?
E0/0.
E0/0. This port will become best port to reach root bridge. But guys, if I have the single root bridge, then this will be always same. What if root bridge ID is same? Like here you can see in my scenario, in this scenario, it might be possible switch 1 and switch 3 are also connected directly like this. So switch 3 will receive BPDU from switch 1 BPDU, root bridge BPDU from two sides, from switch number 2 also and here also, correct?
Right.
And root bridge ID will be same in both the BPDU. Am I right?
Yes.
So if root bridge ID is same, tie, then what it will check?
Cost.
Then it will check cost. If root bridge ID is same, then lowest cost, lowest root bridge, lowest or best root bridge. If it is same, then lowest cost to reach root bridge, right? For an example, in this scenario, as I told you, if there is one more link here, so on this link cost is again 90. When switch number 3 will receive BPDU over here and here root bridge ID is same, what will be the cost over here? 38. What will be the cost over here? 19. So which port will become best port? This port. Where it is receiving superior BPDU? On this port. If switch 3 need to forward any traffic to root bridge, how it will forward? From this port. This port will be in forwarding state and this port will be in blocking state. Done. If cost is also same, if cost is also same, then cost same, then what it will check?
Lower interface value cost.
Which interface? Sender port or receiver port?
Receiver.
If the cost is also same, then it will check designated breeze ID. Designated breeze ID means sender breeze ID. Now, let's suppose here we have one more switch, switch 4. Switch 4 and switch 1 and switch 4 both are connected like this. Both are connected like this. So this time, see, switch 3 will receive BPD over here, Root bridge ID will be 32768 plus 0A. Here also root bridge ID will be 32768 plus 0A. Cost will be what? 19. Here also cost will, sorry, not 19, 38. Here also cost will be what? 38. Now it will check what? Sender bridge ID, designated bridge ID. Designated bridge ID will be what? 32768 plus 0B. Bridge ID of switch 2. And here what will be sender bridge ID? 32768 plus 0 D.
A. D.
D. Right? So now tell me on switch number 3, which port is receiving superior BPDU? Again, this port, right? Which is connected with switch number 3, because here we have lower sender bridge ID or designated bridge ID.
ID.
If sender bridge ID is also same, then it is like this, that maybe this port is connected with one switch whose base MAC address is 0B, and this port is connected with another switch whose MAC address is 0C, and both the switches are connected with one switch whose MAC address is 0A. Cost same, root bridge ID same, right? So now it is going to check lower designated ID, sender bridge ID. On the basis of that, it can select best port. But guys, just suppose I have two switch 1. What happened here? Switch 1 and switch 2. Here we have two link. MAC address is 0A, MAC address is 0B. Switch 1 is my root bridge switch. Root bridge switch. So root bridge will send BPDU from both the port. Let's say this is 0/0, this is 0/1, 0/0 and 0/1. So what will be the sender bridge ID? Sorry, root bridge ID 32768 plus 0A. Here also 32768 plus 0A. Tie on both the interface. It cannot select best port on the basis of root bridge ID. It will check what cost. Cost is 19 here also and 19 over here also. Cost also tie. Now it will check what? Sender bridge ID. Sender bridge ID is also what? 32768 plus 0A. Root bridge is sending 32768 plus 0A. Sender bridge ID also tie. Now what next? If the bridge ID is also same, then
port ID.
Then port ID. Same. Then port ID. Which port ID?
Lower.
Which one port ID?
Sender port ID or receiver port ID?
Sender.
Receiver port.
Then lowest or lower designated port ID. Lowest sender port ID. So sender port ID over here in this BPDU is 128.1. Here is 128.2. So which port will become superior port?
128.1.
This one, right? This port will be in forwarding state and this port will be in
Receiving state.
blocking state. And guys, if I have a scenario like this, if I have a scenario like this where I have one switch here, switch 1, this switch is having MAC address this one, this switch is my root bridge, it is connected with one hub here. Which device? Hub. Example, nowadays we are not using, but just suppose, example, I have one hub and this port ID 0/0 and hub has two port connected with one switch, another switch, switch number 2. Example, right? So when root bridge switch is going to generate BPDU on the both port, root bridge ID same, cost same, sender bridge ID same, destination bridge ID, sender port ID will be also same, right? 128.1, 128.1, this port ID. Now how switch 2 will identify which port is receiving superior BPDU? Switch cannot receive superior BPDU on 2 port. Then there is loop. How it will block 1 port, right? So now switch is going to check what? Receiving port ID, right? If this is 0/0 and this is 0/1, then 0/0 will become root port. Means root port means it is receiving best BPDU. And you know, receiving port ID cannot be same, right? So at this stage, switch can definitely find the best port. Yes or no, guys?
Yes, sir.
Yes.
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 Right? If same, then lower receiving port ID. So just today we have understood what is STP, why we need STP, basic terminology of STP, and how to identify the superior BPDU on switch. Tomorrow you will see the port who is going to send superior BPDU will always become DP, designated port. The port who is going to receive superior BPDU will become root port, and the port, rest all ports will become what? Alternate port, and the status of alternate port will be blocking, right? So you can take one screenshot of this as well, right? Or I'm going to send it here. Today I have not written the definition in notepad. There is reason. In notepad I cannot draw the diagram. What is happening here with charging?
Sir, your voice is stuck,
Yeah,
not
brother.
audible.
Not stuck, I am not speaking.
Okay.
I'm done. I'm done with today class. Just a minute, my charger is not working actually. I will check it. Okay, so here let me take a screenshot of this. This is so important for tomorrow class. STP superior BPDU, and one was BPDU content. Based on these two things, tomorrow we are going to create loop free topology, and after that in any design, right, doesn't matter which type of network design you have, you will be able to design the loop free topology. And once you will be able to design loop free topology, what will understand how to manipulate the topology, like according to my requirement, how I will forward the traffic. BPDU content. Done, guys.